morning and salam alaikum, everybody. Pleasure to be here. I'm going to spend the next 20 minutes to share a little bit of what we do as Microsoft in terms of autonomous driving. Hands up, anyone who knows, again, what are the plans for Microsoft? I mean, we saw Bill Gates around that. But the key area that I want to share that we as a platform provider, we don't build any autonomous driving car. So we work with partners, countries, transport authorities, car makers, to really enable them to be successful in terms of building these very complex solutions. So I'm going to spend the next 20 to 25 minutes. Please stop me if you have any question. Go through in terms of what Microsoft is doing in this industry, both automotive but also in aviation, in terms of building this end-to-end tool chain, but also go a little bit technical as well in terms of describing the reference architecture that we build around autonomous driving. So that's the agenda. I say Microsoft in automotive, AVOps. What does it mean? Most of you are familiar with the term operation, and also looking ahead in terms of the future. So most of you are well aware of the recent trends around technology, around large language models, around AI. How do we use this technology to really enhance the simulation, the validation of autonomous driving cars on the cloud? So again, this is our goal in terms of Microsoft. So our goal as a company is to really look at how can we enable developers, programmers, departments, ministries, governments to really enable them to be successful in whatever they do. So we bring our platform, we bring our tool chain, we bring our expertise in terms of really enabling you in terms of being successful. We don't compete with car makers or airlines in terms of building autonomous flight. Our goal is to really make you successful in whatever you do in your endeavor. So we basically integrate what we do. We as Microsoft, we are probably one of the biggest software company in the world. What are the techniques and tools that we use to really speed up that whole process of validating and certifying cars to run on the roads? And you can see again, I mean, a lot of press in terms of what Microsoft have done in this space. I am based in Dubai. I spend most of my time with car makers around the world, mainly in Europe, so Munich, Gothenburg, Paris, in terms really looking at their challenges in terms of building and validating this autonomous driving car. We saw from Steve that whole hype in the last 5 years around how quickly can we put an autonomous driving cars on the road. It is a very difficult problem. It's probably one of the most complex AI problems. And in this talk, I will share a little bit some of the challenges of really enabling and testing these autonomous driving models. So we see, again, projects at Cruise, GM, at Bosch, Daimler, and Wave, a number of car makers and also solution providers. So these are entities that actually build the software to test and validate. And also, as I mentioned, I work with some transport authority in terms of looking at how do they enable the validation and the verification of autonomous driving cars landing on their country, in a city, in a country. So what have we learned from other parts of the world itself? So we've learned a lot from again, engaging with customers, but also with government entities in terms of looking at what are the challenges in terms of addressing this technology. So very key and critical to this is, again, privacy. So data, and this is across the board in terms of services. It's not just in terms of autonomous driving, but we pride ourselves that the data that you're using to test and validate these vehicles are yours data. You decide where your data is located. We have a data center here in Qatar. We have data center all around the globe. But most of these projects that we have, again, car makers deploying their data across globally. So Microsoft provide that in terms of making sure it's secure and it's protected as well. And again, this is just trying to repeat myself what I said. Again, very critical because, again, that data is critical for you, to allowing you to train and validate your model. And how do you ensure that it's secure? How do you ensure that, again, It's available. Some countries, there again, regulatory challenges in terms of how data is used. We do and work closely with government entity to make sure that your data is secure. Next, I'm going to move quickly in what we term AVOps. So most of you are familiar with the operation within IT, ops, and we've just added autonomous vehicle around it just to bring essentially a set of services that will build that tool chain end-to-end to allow you for validating and simulating your environment. So usually in challenges in terms of autonomous driving is data. So you need to have a lot of data, collect a lot of data from your test vehicles. So you'll see across the road in different cities, these test vehicles with LiDARs, radars, sensors, just picking up, just keep having their eyes open to what's happening on the road. Because without that data, I mean, it's very difficult to train your model. So that data is critical once it's basically is collected. But then how do you share it? What services do you use to share it across multiple environments? And then once it's shared, then you have to make sure that, again, the data that you use is critical for safety and validation. Safety and validation are basically the end goal of autonomous driving cars. There's no point having an autonomous driving car if it's not safe and it's not valid. And with the help of the Microsoft Cloud, it allows you to really scale this environment, test this environment at scale. So instead of testing the physical machine, the physical car, we will build a virtual world into the cloud and test and validate as well. Another challenge that we found as well, mainly in terms of when we look at the trajectory in terms of adoption for the autonomous driving car, is the budget. It's a very heavy business for car makers to test and validate because it takes hours and months and years of data that you need to collect. And collecting that data basically allows you to refine your machine learning model. And finally, scale. So Microsoft, again, build this environment for scalability. You want to test as quickly as possible your environment so that, again, you can get the cars on the road. And that's why we term AVOps. So AVOps, as I say, is a number of services from the Microsoft Cloud. So these are services that today you can go and adopt and consume on a separate entity. Let's say you want to build a development pipeline, you can do that separately. But we as Microsoft have put together a number of these different services, starting with again, cloud to car. So this is basically ingesting data from a car to the cloud, moving it to the data operation. So this is where once the data is landed on the cloud, you use that data to refine it, to clean it, and that data can be road condition, can be traffic data. So all that data, again, is coming in a single place. Again, what tool and services do I have to allow you to do that? And then you go through your normal DevOps environment. So developing your simulation stack, making sure you have traceability around that. And that's really critical because when you look at deploying a machine learning model in a car, you need to be able to trace from start to finish the source of that data and what data was used to train that model. Because in case of a safety failure, an accident, authority will come to you and say, okay, can you prove to me what data was used to train that model? And that's critical. In all the car makers, that's probably one of the biggest challenges they have, traceability of data. So what data did you use to train your model? And have a full view of that. As well as that, you have also MLOps. So this is the machine learning operation. So I'm building a machine learning model, but I need to find out in terms of version control, traceability as well. Is this model the right model? Am I using the right version? And all these moving parts is a big challenge to car makers. So cars are becoming essentially a big software engineering house. Moving away from the mechanical car, we're moving more to a software-defined vehicle. So all these moving parts, we as Microsoft are trying to pull this together in terms of what AVOps talks around. And again, the solution is pretty straightforward. You have your test vehicles that collect cars, and those cars, that data is either transferred to the network, which is very expensive, or offline. So we have solution offline where data is collected from a copy station, which can be your own data center, and then moved to the cloud. And the goal of that migration is to make sure that you have the compute, you have the storage to house those data. On average, a test vehicle on every given month will probably collect something like 20 terabytes of data. And you multiply that by 10 fleets, you're very close to the petabytes. So we're talking about a big data problem that we're trying to solve using the Microsoft Cloud. And at the bottom there, you can see some of the name of these providers, Mobileye, Qualcomm, and NVIDIA. So these are the silicon vendors that actually build devices on the car itself. And once they build those devices, and these devices, the CPUs are used for, let's say you want to fuse the different sensors that are coming in through the car, use that information, and the goal of that is to have an equivalent environment in the cloud so that you can validate what the car has seen. So the car is running an NVIDIA chip or a Qualcomm chip. We basically have that same mapping in the cloud. So you can simulate in real time what the car is actually seeing. So that one-to-one mapping is critical in this environment. And this is, again, a high-level reference architecture in terms of, again, how we see the world. And we've learned a lot from car makers. This is not our architecture. This is the industry architecture in terms of the different components that allows you to effectively collect data, cleanse the data, label the data, use that data to build validation model, perception models, and finally test that effectively in a really safe environment. You will see many services like data ingestion, data archive. So archiving is very important, as I mentioned, in terms of safety and validation. Authorities will, in some countries, will say you need to keep that data for 7 years in terms of, to make sure that, again, if there's a problem down the line, we can go back and retrieve that data that was used to train that model. So the gravity, the traceability of data is a really critical part of this environment. The other services, basically, they leverage on what we do as Microsoft in terms of scalability. My background is mainly building large-scale big data and supercomputers just to validate the data that you've collected, to make sure that the data that I've collected, I can trace it, I can use it to build my machine learning model. And yeah, that's our approach. So we integrate all these development processes into one platform. And it's a really open platform, so customers will have different level of maturity of their platform, so they can very easily integrate that platform. So it can be car makers, it can be authorities that have already got a platform to really test this environment. But the key is, again, very open platform. And next, I'm just going to go quickly in terms of, again, the different persona in terms of people involved in terms of building this environment. So you can have a test driver. So this is a person that will drive this test vehicle, and the primary job of the test driver is just to drive and collect data. Data about traffic condition, about, again, pedestrian walking in the street, about cars in front, cars in the back. And that data, once that data is collected, that data is moved to the cloud. And then you have the scenario manager. So the scenario manager's main job is to look at, are there any edge cases to allow me to train my model? So an edge case can be, okay, I'm doing a left turn, but there's a traffic light. Can I collect as much data on that to allow me to train my model? Likewise, there's a labeler. So labeler is probably a very manual intensive task today. The reason it is because, again, it's very difficult for computers to do computer vision. So we've progressed significantly in how quickly we can really detect and classify objects. Today, it's really semi-automated. So some of our services allow you to really automate that process. You have the data engineer. So again, all these engineers are critical into this whole tool chain. We have also the person responsible for building that perception model. So they're looking at a data scientist building that machine learning model. And at the end, you have also the validation and simulation engineer. So this is once all the data is prepared, all the machine learning models are ready, how do I scale it? How do I test it at scale? You even see environments where a whole city has been built in the cloud. A virtual city with cars, and where you can inject edge cases, a person driving, walking with a bicycle at a traffic light. So all this can be basically built as a digital twin of a city. And the goal of it is to speed up that process of validating a test vehicle. And this is, again, a bit complex in terms of, again, what it is. This is the end-to-end journey. So you start with collecting the car, the test vehicle, pulling that information, uploading it into the cloud. Once it's uploaded, okay, I have data now. What do I do with data? Do I keep some of the data? Do I throw it away? So you have a lot of flexibility. But based on your requirements, if you want to look at something really specific, you have, again, your data engineer will come in and just sift through that data and prepare that data for the next stage. So we see this whole journey as really cyclical. Machine learning are created and they are optimized by providing more data into the tool chain. And yeah, data ingest, data is corrected, you are tested, trained, and simulated. And then you build and validate. So the validation exercise is a final step, but then it's never-ending step. You always want to refine, hence the delay in terms of having these autonomous driving cars on the road. And here is just a snapshot of the different sections. So the vehicle drive upload, who's responsible for it, what do they use, what services within the Azure cloud they use to do that, the scenario capture. So this is looking at really the services within Microsoft that allows you to capture that information and cleanse that information. Data curation and extraction. So what are the services used in that space? And what's happening, and as I mentioned at the start of the talk, is we're starting to look at generative AI to really speed up that process of generating data. So instead of just collecting that data, I want to build synthetic data. And that today we're starting to see the integration of large language models, but also via VLMs, visual language models. So I'm describing my scene. So today, let's say you collected data on a nice sunny day in Doha. How do I inject rain, for example? I'll describe that using a language model. Please include rain at that specific location, and that can be generated into a video file that can be integrated on your data itself. So technology is moving really fast. We've got a project called Project Florence, which actually just looking at how do we incorporate language models with computer vision. So I'm describing my scene. I'm creating my scene. You're doing scene generation as opposed to just capturing real-time ground truth data. So you're actually creating that scene for testing and validating your models themselves. And then, as I mentioned, data labeling, data tagging, even also in terms of that process of data labeling. So as our models are getting more sophisticated, that process is becoming more automated. So an object using computer vision, because you've already described it, then it's much easier to label it as you go forward. Likewise, the perception training. So this is where we've seen also the availability of GPUs around the globe and how important it is for people to have access to GPUs just to make sure that I can train my model at scale. So the more data I have, the more compute I require to validate that. Likewise, in terms of simulation and validation. So these are really large. I was working on a project in France, and they were building a cluster of 65,000 GPUs just to simulate and validate. And that brings a lot of complexity and challenges in terms of how does it work. Again, high-level architecture design, I'll leave it there for you to have a look. But again, as I repeat, these are the building blocks that we use for our reference architecture. And here, again, in terms of the infrastructure, the hardware, how do we manage it? How do we process it? How do we orchestrate it? These are all underlying services that come with Microsoft. Nothing new here. And the services, compute critical. So all these customers are building farms or coming and consuming our large GPU farms and CPU farms just to do validation and simulation or model-based training at scale. Really important in this environment. And again, some options of some of the hardware we use. And again, more information around some of our GPUs. And partners, again, Microsoft is a really partner-led organization. So we work with a lot of partners. What you saw in terms of the reference architecture is a reference architecture, but we're bringing some of the partners. So if there's any partners in this crowd, feel free to come. We can discuss how you can integrate your tool chain. It can be something specific like data labeling. It can be building a new scenario generation tool. We really work very closely with these partners. Next, I'm going to just quickly jump into, again, the future trends around this space. The whole space around autonomous driving is how quickly can I put a car on the roads safely, in a secure way and a safe way. And to do that, driving millions and millions of miles will take us so many years. So one of the trends is, again, the move to building virtual cities. So see building like Doha as a digital twin, ingesting your test vehicle and driving around just to see, again, teach the car how to drive in a city. And that's where we're seeing the trend going towards. And that's where we are using, we are very familiar with some of our tools, Copilot. And Copilot services have been integrated today in most of the traditional Microsoft services. And this can be to speed up software development. This can be to speed up how I build my reference architecture. Can be how can I help my scenario manager to say, okay, find me, I don't know, data, videos, images that allow me to better train my machine learning model. So we're starting to see a lot of our products, and you can see the Copilot sitting next to the data engineer, the Copilot sitting next to the developer, and the Copilot sitting next to the validation engineer. So these are services today that have been integrated as part of our toolchain to really reduce the time it takes to test and validate this environment. And the platform, as I say, GitHub is the first one. So you probably heard about GitHub Copilot, really allowing you, your experienced developers to really speed up their process of developing software in terms of collaborative productivity and security as well. And that's my talk. Any question, feel free to ask.